questions.
Okay, so let's have a look at this experiment. Mr. Russell's wandering around being annoying and waving rulers about things. He really has taken over the role of Mr. Baker. When I was doing this during the last lockdown, Mr. Baker was the one who was always in, irritating me. Right, so we need to just check the depth. Now, you can perhaps see on the screen there that finding the depth is far from easy. You know, actually reading what depth that's at is not an easy thing to do, and it suggests in the notes that we've got to do it 3 times. So I reckon that that one is reading 12 mil. Pop it in the middle. Struggling to read that one. Well, I think that one's probably reading 14 mil. And we'll come right over here. I'll do it in the light. That one's going to read 13 mil, so when I do my average on that, my depth is going to be 13 mil. But not easy to read the depth at all on this, so it's one of the difficulties with this experiment, is getting a good value for depth. And then what we're going to do is we're going to create our wave. Now I'm just going to switch to a wider view on my camera, so you can actually see what's going on. So what I've got is my tray of water now is up on a ruler, so I've got a ruler lifting up one edge. And pulling that ruler out sharply will create my wave, and because I'm using the same ruler each time, it will nice and consistently create my wave. So if you watch carefully, I'll create a wave. And you see the wave going backwards and forwards there. Unfortunately, we start getting multiple waves after a while. It gets quite hard to see what's going on. So I suspect I will be able to see better in the room than what's happening than you can on the camera. What we're trying, just pull that out of view a little bit there. It's not quite in the camera. There we go. So we've got to record the crossing times as we do 1 crossing, 2 crossings, 3 crossings, 4 crossings, as many crossings as we can manage to record the times for. We need to record the time to travel the total length of the tray, so we need to have a good look at that. And I'm just again going to zoom in so you can have a good tight look at that. So zoomed back in again. And it's nice that my camera's got 2 lenses. I'm going to just... Yeah, so what was going on there? This is what we've got to sort of establish between ourselves. This is what the guys in the room are having to establish. What's going on there? When do we start the stop clock? And you might notice, if you're really concentrating, that the point it drops and hits, which is when you might be tempted to start the stop clock, is not when the wave first appears over on this side. The wave first appears over on this side a fraction of a second later. So I need to start recording when the wave appears here, so that I can get 1 complete length of the tray, or 2 complete lengths of the tray, or whatever, not at the point when I do my drop. So that's going to be easier said than done, but is what we're aiming for. Right, I'm going to go back out to the wide view. Okay, so I've put it back on wide view so you can see what I'm doing, and we'll try and make some recordings. So, 1. So 1 read 0.93. Let's try for 2. One, 2. So 2 read 2.13. Let's try for 3. One, 2, 3. 3 read 3.41. Let's try for 4. 1, 2, 3, 4. 4 did 4.56. Let's go for 5. 1, 2, 3, 4, 5. 5 did 5.50. Let's Let's go for 6. One, 2, 3, 4, 5, 6. 6 was 6.93. Right, it looked to me like I could probably get 7. I might struggle to get 8. So let's try for 7. 1, 2, 3, 4, 5, 6, 7. 7 gave me 7.93. Right, we'll give 8 a go, shall we? One, 2, 3, 4, 5, 6, 7, 8. I'm not sure I believe that one, but we'll put it in. 9.18. That reads. Okay, so obviously this is physics, so we've got to do repeats. So we go back to the beginning as always and do the experiment all over again. So let's do repeat number, second set of results, the second set of repeats. So 1 crossing again. 1. So this time I got 1.12. So clearly you can see that it depends rather a little on when you decide the wave is at this end, which is a little bit of a guesstimation. Right. And take this ruler out of the way. That's Mr. Russell annoying me. Okay, 2 after, aren't I? 1, 2. 2.06. And 3. 1, 2, 3. 3.37. And 4. 1, 2, 3, 4. 4.68. And 5. 1, 2, 3, 4, 5. 5.56. That's the closest one so far to the one before, isn't it? Oh no, 3 was pretty good as well. Okay, 6. 1, 2, 3, 4, 5, 6. 6.87. It's not easy, that one, because when it's disappearing, it sort of disappears into the shadow at that end. The even number ones are harder than the odd numbered ones because of the shadow. But I have to have the shadow there because if I light it from above, then you get the reflection of the light in the video. So I'm having to light it from the side to give you a chance to be able to see the waves. Right, what have I got to? 7. 1, 2, 3, 4, 5, 6, 7. 7.82. And finally, let's try for 8. Might be that 8 ends up being an anomaly when we graph it, but we'll try for 8. 1, 2, 3, 4, 5, 6, 7, 8. 9.15. Okay, what are we back to? We're back to number 1 for our final set of repeats. So, final set of repeats. assuming that they come out pretty much close to the previous ones, that is. If they came out completely different, I'd have to do them all over again, because that's just good science. Assuming they come out to be the same as the previous ones, then this will be my final set. Okay. 1.93. Don't know what I'm doing. 2, isn't it? 1, 2. 2.13. Oh, I got that very first time. And 3. 1, 2, 3. 3.46. I think I went a bit early on that one, but never mind. And 4. 1, 2, 3, 4. 4.46. Oh, overcompensated by being a bit late on that one. Okay, what have I got to do? 5. 1, 2, 3, 4, 5. 5.65. What are we at? 6. 1, 2, 3, 4, 5, 6. 6.96. Do you think the even ones are hard, because I just don't see the wave in that shadow. So if you were writing a conclusion, you might say something like that. Okay, 7. 1, 2, 3, 4, 5, 6, 7. What's that? 8.01. Went a bit long on that one, didn't I? And final one, let's try for an 8. One, 2, 3, 4, 5, 6, 7, 8. 9.12. Okay, that's it. That's the results. If this was my set of results, I would then have to calculate a mean, calculate an average for each one of the number of crossings. I'm then plotting a graph, and based upon the shape of the graph, I've got to make a decision as to what conclusion I'm going to draw. Is the wave getting faster? Is the wave slowing down? Or is the wave travelling at the same speed? The shape of my graph should conclusively be able to tell me which one of those is true. Now obviously I've got a little bit of scatter on my graph. Depending, the start point changed a little bit as I was looking for that wave starting at that end. I might have gone a bit too early each time, I might have gone a bit too late. But all that does is that moves the zero, that moves my graph up and down a little tiny bit. It doesn't change the shape of the graph. That's what I've got to do now. Calculate a mean, plot a graph, write a conclusion. And that's what you guys at home will have to do with this data as well. Okay, thank you. See you.